Back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. In this video, we are going to be talking about discrete probability distributions, okay? It sounds like something that's super complicated, but guess what, y'all? It is not complicated. So just bear with me, follow through with me, and you're going to find out that it's pretty easy. All right? So first of all, what is a random variable? A random variable is a numerical measure of the outcome from a probability experiment, and its value is determined by chance. So it's basically some type of measure that results from the outcome of an experiment, okay? And again, it's random, so that's why it's determined by chance. Random variables are denoted using letters such as, we use this one a lot, capital X, but the letter can also change, but this is the most commonly used one, capital X. Now, discrete random variables, those are random variables that has either a finite or countable number of values. That means the measured value that you're getting from the probability experiment can be counted, okay? Versus, and the values of discrete random variable can be plotted on a number line with space in between each point. So basically, it's only the countable numbers, 0, 1, 2, 3, 4, nothing in between those numbers, all right? That's what it means by space between each point. And then I was going to say versus continuous random variables. With continuous random variables, you have infinitely many values, okay? There are infinitely many possibilities. And these can be plotted on a number line in an uninterrupted fashion, such as something like this. So this one has 2 dots, and it's everything in between it is shaded. So last one we had just the number 0, 1, 2, 3, and 4. But on this one, since it's shaded, you can also have numbers in between 0 and 1, in between 1 and 2, such as 1.75, 1.638. So these numbers can also be included. Another way to determine the difference between discrete and continuous is most of the time continuous random variables are measured, all right? And you also want to ask yourself, can a number in between two numbers be a possible outcome? If it can, then that is a continuous random variable. So let's look at some examples of some random variables, and we want to determine whether they are discrete or continuous. So if we wanted to measure the amount of rain in Seattle in April, and the key word here is measure, but think about your outcomes. If you measured the amount of rain in Seattle, you could get 1 inch, 2 inch, 3 inch, but could you also get possibilities in between 1 and 2, like 1.4 inches, 2.7 inches? Yes, you can. So if that's the case, this is a continuous random variable. The number of fish caught during a fishing tournament. You can catch 1 fish, 2 fish, 3 fish, 4 fish, 5 fish. Can you catch 5.5 fish or 5.25 fish? Nope, you cannot. So this would be a discrete random variable. The number of customers arriving at a bank between 11 and 12. You can have 1 customer, 2 customers, 0 customers, 4 customers. But can you have 4.4 customers or 4.5 customers? Nope, you cannot. So this would be a discrete random variable. And then the last one, the time required to download a file from the internet. Time could be 3 seconds, 10 seconds, but could it be 10.5 seconds or 10.2 seconds? Yes, it can. And so since it can be the values in between, this will be considered a continuous random variable. All right, so that's continuous versus discrete. In this video, we're going to be mainly talking about discrete, but you just need to know the difference between discrete and continuous. So a probability distribution of a discrete random variable X provides the possible values of the random variable and their corresponding probability. So a probability distribution is going to give you all the possible values of the variable X and also the probabilities of each of those possibilities. A probability distribution can be in the form of a table, a graph, or a mathematical formula. And so there are 2 rules for a discrete probability distribution. All right, so the first rule is that the sum of the probabilities have to add up to equal 1, which we've seen this before. And also the probability of the random variable X has to be between 0 and 1. And we saw this rule before. Both of these rules apply to probabilities. So the sum of all of the probabilities in the distribution have to equal to 1, and each probability has to be between 0 and 1. So let's look at an example. This is an example of a discrete probability distribution. It has our possibilities over here, 10, 20, 30, 40, 50. Those are the possible values. And here is the probability of each one. We want to determine if this is a discrete probability distribution. So remember the two rules was all of the probabilities have to add up to 1, and all of the probabilities have to be between 0 and 1. I notice here I have a negative probability, which is impossible. I can't have. And so therefore, this would not be a probability distribution. Why? Because I have a probability here that is not between 0 and 1. Let's look at another example. Determine if the following is a discrete probability distribution. So these are all of my outcomes, 0, 1, 2, 3, and 4. And this is a probability of each. 0.2, all of them have the same probability. All of the probabilities are between 0 and 1, so that rule is met. The second rule we will need to test is, do these add up to 1? And if you were to add 0.2 and 0.2, that would be 0.4. Add another 0.2, that would be 0.6. Add another 0.2, that would be 0.8. Add another 0.2, that will be 1. So yes, these add up to 1. They're all between 0 and 1. So yes, this is a probability distribution. All right. So that's how you can look at a table of values or a table of a possible discrete probability distribution and determine if it really is by checking those two rules. Let me know if you have any questions about this. All right, here's an example. Construct a discrete probability distribution for the variable x that represents the ideal number of children to have in a family. The following data represent the ideal number of children for a random sample of 900 adult Americans. All right, so people were asked, how many children do you think is ideal to have in a family? Yeah, I used to want to have 5 kids until I had 1. When I had 1, I said I wasn't going to have any more. But then I said I didn't want my child to grow up as the only child, so I had 2. So for me, 2 is the ideal number. And as you can see, look at the frequencies. A lot of people agree with me, but not everybody agree with me. Some people think none. Some people think 1. Some people think 3. Some people think 4. Some people think 5. Some people think 6. Okay. And so what we want to do is we want to construct a discrete probability distribution that represents the number of children that people think you should have, Americans think you should have. So what we want to do is create a table, and I have my table here with all of my possible outcomes. And in this, based on this survey, the possible outcomes were 0, 1, 2, 3, 4, 5, and 6. So these are my possible outcomes. And now what I need to do is calculate the probability of each. And in order to calculate the probability of each, I first need to know what is the total number here. And it's basically just the total number of adults that was surveyed, 900. So when I add all of these up, they should add to 900. So our total number is 900. And I need to know that because remember, in order to calculate the probability, you do the number of each one divided by the total number. So for 0, we'll put how many zeros there are, 10, divided by the total number, which is 900. And if you divide that out, you end up getting approximately, I'm going to round it to 2 decimal places, 0.01. And we'll do the same thing for 1. There are 30 people who said that it should be 1 child. So you will do 30 divided by 900. Divide that out. And if you round it to 2 decimal places, you get 0.03. We're going to do the same thing for 2. 520 people said there should be 2 kids. So do that divided by 900. Divide it out and you get, and round it to 2 decimal places, 0.58. For 3, there are 250 people who said there should be 3. So 250 divided by 900. Divide that out and round it to 2 decimal places, you get 0.28. For 4 kids, there were 70. So 70 divided by 900. Divide that out, round it to 2 decimal places, you get 0.08. And then for 5, there were 17 people. 17 divided by 900. you get 0.02. And then for 6, there were 3 people. 3 divided by 900. If you round that to 2 decimal places, you get 0.00. So basically, almost there's a 0% chance of 6 kids, of somebody saying that the ideal number is 6 kids. So this is our probability distribution. This is how you do it. Basically, you just list all your possible outcomes with the probability of each. So this is how you would create it. So that's it. It sounded complicated, right? But it's pretty simple. That is how you make a discrete probability distribution. Please let me know if you have any questions about that or this. And if not, I will see you all in the next video.